Welcome back, everyone, to the eCoreAcademy e-learning platform. My name is AJay, and I'm going to be back with you guys for yet another Algebra 1 video for you all. And today we're going to be coming to the summit, the culmination of our second chapter in our Algebra 1 course entitled Absolute Value Inequalities. Now, the reason why this lesson is actually called Absolute Value Inequalities is because in this three lesson, very short chapter, second chapter, we've been building up to this very lesson, to this very topic of being able to cipher and identify our absolute value inequalities. We started off by looking at regular and compound inequalities, then looking at absolute value properties and expressions and equations, and now we're going to be combining both to actually look at the different scenarios of absolute value inequalities and how they can be represented on the number line. We'll also be going through graphs of absolute values later on in this course itself in a separate chapter, so also stay in tune for that. So now that we've built up to this, I'm really excited for this lesson. This is something that a lot of people oftentimes get confused with, so just please make sure to stick with me throughout this lesson. I'm going to try and break it down into the simplest terms. So I'm going to start with an informative slide, trying to give you guys different sequences, steps, and also trying to validate, give you a reason why there are two different scenarios for greater than or less than inequalities, for absolute value inequalities, and then I'll go into a problem, and then finally I'll show you what it looks like on a number line and how to graph it. Just a simple review from our compound inequalities. But before we do that, please make sure to do 4 things. Please make sure to smash that subscribe button down below, hit that like button on this video, turn post notifications on, and also check out and utilize that comment section down below to leave us any feedback or any future suggestions for videos. Also, utilize that share button on the YouTube right on the YouTube Dropbox. It's very useful for all of us, and you can also utilize our social media platforms as well and forward it to anyone who might need it and share all of our videos. So thank you for that. And as I was saying, just to summarize this, we're going to discover what absolute value inequalities actually are and how to solve them in 2 major scenarios. We looked at simple absolute value inequalities in our absolute value video. Now we're going to be advancing it and looking at compound statements with absolute value inequalities. So without further ado, put your seatbelts on, your learning seatbelts on, fasten them up, and let's get right into it. So for our overview of absolute value inequalities, I'm just going to summarize what these actually are and what we're really getting into. So this is all about expressions and inequalities. So why am I titling this slide Expressions and Inequalities? Well, if you take a look at absolute value inequalities, they always involve your greater than, less than, or your comparison sign, less than or equal to, greater than or equal to, so on and so forth. And then you also have your absolute value equation, which normally has an expression within identifying something with your variable. So using the same methods as the previous lesson on absolute value, we will be utilizing the isolate, split, and check methods for the inequalities containing absolute value expressions. So there's always a 3-step process when solving absolute value inequalities or just equations in general, like we did in our previous video. That's linked in the description box down below. That's isolate, split, and check. So what you're going to do for isolate is you're merely isolating that absolute value expression. Everything within absolute values is going to be isolated on one side. Everything else is moved to the other side so that you can solve just for that absolute value equation. Then you're going to split it up into 2 different equations, or 2 different inequalities in this case, and you're going to essentially flip the sign for your inequality. For one of them, you're going to flip the sign and change the sign of your integer. So instead, say for example, it's x is less than 6, absolute value of x is less than 6, then you're merely going to take x is less than 6, your original equation, and then afterwards you're going to alter that to say x is greater than negative 6. So you're flipping the sign, changing the sign, making them opposites, making 2 equations opposites. And the only difference in absolute value inequalities when you're solving them is that there are 2 different types of inequalities for greater than and less than, and each scenario will represent a different compound inequality. So just to give you a little spoiler, you're just going to be solving these absolute value inequalities just as you normally would an equation, except that you would utilize the inequality property where you make 2 different scenarios, and you'd flip the sign, change the sign of the integer as well for one of them, and then keep the other the same. And then also with greater than or less than, each one of those different comparisons actually has a different compound inequality. So less than, you would always end up with an AND answer with 2 different solutions. With two different data sets, converging and actually intersecting. And then for your greater than, you're actually going to have an OR statement in this case for the solution. And I'll talk about why exactly this happens. And just to recap, absolute value inequalities, they still provide a range for the variable you're solving for. So I know it might be different, the whole process of getting there, but once you get to the solution, it's your same standard solution. It's merely a set of inequalities. So you're always giving that a valid range for your variable x in this case. And you can also solve inequalities just like expressions and also like equations, but remember the negatives rule. So you can always solve them like expressions and equations, but the negative rule is the only special rule in that case, in which when you divide or you multiply by a negative to either side of the inequality, you're actually going to have to flip the sign whilst doing so. All right, now let's move on to our next slide and actually look at our less than inequalities. And something that I've already wrote down was less than. So when you take a look at this slide, I've titled it less than and that's really to show you the acronym less than. The reason why I put that there is because your less than inequalities, whenever you simplify your less than inequalities and you're given your final solutions or two separate inequalities, they're always going to be an and statement, meaning they're always going to merge as an and statement as a compound inequality. And I'll explain exactly why. So for all absolute value inequalities that are less than and less than or equal to, so it can be either one of those, they will all represent and inequalities for the variable you are solving for. So the final solution, you're always going to have an and statement of those two separate inequalities you solve for. And because absolute values make makes the opposites the same number, like I said before in my previous video, if you have like a -6 and a +6, those are both direct opposites. But once you put them inside absolute value bars, you're actually going to get the same value of +6. So in that case, the graph of a less than inequality will be fluid without any breaks, because it's what essentially it's saying is in a less than inequality, your final answer is going to be greater than the smallest value and less than the greatest value. So that means they're going to emerge and they're going to have finite points as an and compound inequality. So just to give you an example, let's take a look at the absolute value of x less than 6. This isn't even a formal expression. This is literally just one variable. So it's a lot less complex, so I can show you exactly what I mean. So the absolute value of x are given to be less than 6. Now, what can that translate to? That translates to x is greater than or equal to greater than -6, because what we do is we take that variable x, we flip the sign and change the sign of the integer, so it's going to be greater than -6, and we're also going to leave it the same. X is less than 6, so we're going to keep one way, meaning we don't alter we're making them direct opposites of each other. So the two direct opposites are x is less than 6 because we aren't altering the sign or the integer. And then the other value is going to be x is greater than -6 because remember, we're always going to flip the sign for the second choice, flip the sign and change the sign of the integer as well. And how else can we simplify that? Well, since we know that it's an and statement and in a compound inequality, we can utilize our knowledge from our first lesson in this chapter, compound inequalities, to tell that -6 is less than x is less than 6. And inequalities, you can always write it like this because x is greater than -6, so that means -6 must be less than x. And since 6 is also greater than x, then that means -6 is less than x is less than 6. Now, let's take a look at the graph of it, just to prove to you that this really is an and inequality, and that this will be consistent throughout. So let's take a look at our -6. So x is greater than -6 in this case here. So x is greater than -6. So we're going to put a open circle at -6 because it's not included. And we're going to go etch. We're not going to etch yet, but we're going to mark off our x is less than 6 here. So we're going to also put a point at +6 here. Now, we know that x is going in a right manner from -6, and it's also going leftwards from 6. Now, because there's two finite points that you're given, it has to be within that data set, so that means it's going to be one fluid graph. All these points in between are also valid values that can go for x, all valid values right here. And because it's an and statement, that just shows that it's one fluid graph, no breaks like an or statement. All right, now let's move on to the less than inequalities actual practice. So I'm going to show you an actual expression, break it down with you, and actually explain everything you need to know for the less than inequalities. So really stay in tune to this slide. So we're going to start off with our first step. We're going to isolate. We're given our first problem. This is what your problems are going to look like. We're going to be given -3 times the absolute value of x plus 5 is greater than -9. That's our original problem. Now, what are we going to do? We're going to isolate that absolute value sign. So the only thing we need to do is get rid of that -3 with the x plus 5 so that x plus 5 is on its own in the absolute value sign. So what are we going to do? We're going to divide both sides by -3, and that gives us the absolute value of x plus 5 is less than 3. Now, Remember the negative rule. The negative rule always implies a swap in the sign, in the inequality sign, and also a swap in the sign of the integer value itself. So when we divide by -3, it cancels out -3 from the x plus 5 side, and then when we divide -9 by -3, we're given a 3, and here we're merely flipping the sign as well because you divided by a negative. That's what the negative rule means. When you divide or multiply by a negative, always flip the sign. Then we're going to go on to our second step, which is you're going to split the two inequalities with opposite signs and opposite values. So we're going to take one sign with, we're going to take the original equation here, x plus 5 is less than 3, and then we're going to take its opposite, which is x plus 5 is greater than -3, because we flip both the sign and the value itself. So our first equation here is going to be x plus 5 is less than 3. And our second equation is going to be x plus 5 is greater than -3, because we took direct opposites of each other. And then finally, we're going to check and we're going to evaluate each one of those inequalities. So on the left-hand side, we have x plus 5 is less than 3. You're merely going to subtract 5 from both sides, and you're left with x is less than -2. Then on the right-hand side, we have x plus 5 is greater than -3. So you're just going to subtract 5 from both sides as well. So -3 minus 5 is -8. So x is greater than -8. And as you can see here, because x is less than our greater value, -2 is greater than -8, just as a FYI. So since x is less than our greatest value and it's greater than our smaller value, that means they're going to both emerge in the middle. So that means they're an and statement. It's going to be a fluid graph all the way throughout. Now let's take a look at our graphing. How exactly would we graph this? So this is less than inequalities graphing. So this is specifically going to entitle our graph of and. So we're given our final solution. Remember, our final solution was that x is less than -2 and x is greater than -8. But of course, we can write it as -8 is less than x is less than -2 because it's an and statement and it's one fluid graph. So let's graph this. So we have -8 right here. We're going to circle -8. And then we're going to go directly over to -2. We're not going to start graphing our line yet because we know it's an and statement. So we're going to also graph on -2. And we know that it's going to be greater than -8. So it's going to go over to the right from -8. And then it's also going to be less than -2. So it's going to go over to the left to -8. From -2 to -8. So it's just going to be one continuous set of values here. Just one continuous data set, all valid. Just wanted to get space there to write all valid values. All right. And then just as a FYI as well, whenever the reason why less than inequalities are always and inequalities for the answers, it's just the fact that x is greater than the lesser value. Like I said before, x is greater than your -8, and it's also smaller than the larger value of -2. So that means it's going to be directly in between both of those values. And this also works for less than or equal to. I just utilize that less than inequality not to confuse you guys, but this can also work for your less than or equal to inequalities. And then greater than and greater than or equal to are their own separate entities, which we'll be getting onto next in this second half of this lesson. So let's move on to greater than inequalities. So one way that I really like memorizing greater than is actually looking at greater, that first part of that greater than statement. We have great or. So we have great or as an acronym. This means that it's going to be an or statement for greater than. So for all absolute value inequalities that are greater than and greater than or equal to, they will all represent or inequalities for the variable you're solving for. So once you simplify, you're going to simplify exactly the same as your less than inequalities. All absolute value inequalities are going to be solved just exactly the same with those 3 steps. It's just that the final answer is whether or not you put or and. That's what we're figuring out here. And for greater than, it's always going to be or. So because absolute values make opposites the same number, the graph of a greater than inequality will not be fluid and will always have a break in between. If you remember our or compound inequalities, they're not going to intersect, and they're actually going to have a break in between, and they're going to go in opposite directions. That's exactly what's happening here. And the reason for that, just a little spoiler, is because in a greater than inequality, when you always simplify to the final step, you're always going to be given your 2 inequalities. One's going to actually state that it's greater than your greatest value, and the other one's going to state that it's less than your smallest value. So that means they're going in opposite directions, left and right, and they won't ever intersect. So let's take an example here. Let's take the absolute value of x being greater than 8. It's a greater than inequality with an absolute value. So that would transfer to x is less than -8, because remember, we take two of the opposite values of the original equation with opposite signs and opposite values. So we have x is less than -8 because we flip the sign and flip the sign of the integer value of 8, and we also have we also have x is greater than 8. Now, just to show you guys what that looks like, let's graph it. Let me show you exactly how this represents an or statement. So let's take a look at our -8 here. And then let's also circle our 8 here. It's open circles because it's not included. It's not a greater than or equal to. So here we have that x is less than -8. So that means it's going to be going leftwards from -8. So we're going in this direction right here. And then over from here, I just bold that for you guys. And then from here, we have x is greater than 8. So that's going to be going on to the right, onwards to the right. So they're going in opposite directions, and there's this massive break in the graph. This clearly shows your or statement, and it proves that because of your x being greater than 8, absolute value of x being greater than 8, it's all values that are essentially greater in integer value without the negative that are greater than. So if we take a look at this graph, just to explain it to you, think about it. If we have -8, if we have the value of -8, we're merely changing it to a positive value, and it has to be greater than 8. That means that everything from -8 less than -8 is going to have a greater integer value, like -8, -9, -10. That's all going to translate to 8, 9, and 10. Those are all greater values of 8. You can't have anything greater than -8 because that's going to be between -7 and 7. And when you take the absolute value of all those values, it's just going to be less than 8, period. But then also when we take +8 through, positive infinity, 8, 9, 10 onwards, you take the absolute value of that. It doesn't change the value of the integer, and it's just going to be greater than 8. And of course, -8 and 8 aren't included in this graph. All right, now let's take a look at a greater than inequality practice problem, actually putting it into, putting it into work and taking an example. So let's start off with our first step called isolation. So repeating the same steps as our less than. The only part that's different is our final answer. So we have the inequality of -4 times the absolute value of x plus 3 is less than -8. Now you might be thinking, wait a second, isn't this a less than inequality? Well, think about it. It's technically not a less than inequality because both of the sides have a negative with them. So when we simplify it, we're going to use the negative rule and we're going to swap it. So we have -4. We're going to isolate the absolute value of x plus 3. We're going to divide -4 from both sides. That cancels out from the left side, and it turns -8 into a 2. Because we divided by a negative, you're also going to flip the sign, and now it's going to become a greater than inequality. The absolute value of x plus 3 is greater than 2. Then for our second step, we're going to split. We're going to have two separate inequalities that have opposite signs and values. So our first inequality, we're just going to take the absolute value bars out for our first one without changing anything to it. So we're just going to have x plus 3 is greater than 2. And then for our second inequality, we're merely going to flip the sign and also change the value of 2 of your comparison. So it's going to be x plus 3 is less than this time. And it's also going to be less than -2 as well because you flipped the value of 2. Now, we're going to check. We're going to solve each inequality separately. So we see that x plus 3 is greater than 2. We subtract 3 from both sides, and we get that x is greater than -1. And then on the right-hand side, we have x plus 3 is less than -2. We're going to subtract 3 from both sides to get that x is less than -5. And this is going to be an or statement. Now, if you think about it, like I said before, an and inequality is when you're less than your smallest value, your lesser value, x is greater than your smallest value, and it's also less than your greatest value, so it's in between that continuous graph. But in this case, it's great. It's actually greater than your greatest value. -1 is greater than -5, so it's greater than -1, and it's also less than -5, so it's going in opposite directions, and they won't ever intersect. And also when you're writing it an or statement, you cannot combine it like a fluid graph like you would in terms of, like, say, for example, if it was -5 is less than x is less than -1, you can't write it like that. Or statements are just two separate inequalities. You can't make it one fluid inequality with 3 values. All right, now let's take a look at graphing our final slide for this video. So let's take a look at the graph of or with this greater than inequality. With our answer, we have x is greater than -1 or x is less than -5. So let's take a look at the graph. We're going to take a look. We're going to pinpoint both of our points first. And we're going to put open circles because it's a greater than sign, not no less than or equal to. So that's why. So we're going to circle -1 on this graph, and then we're going to circle -5. And because it's less than -5, we're going to be going towards the left, always on your number line, towards my left. This is my left. So we're going to be going towards the left here. All right. And then for this inequality, for -1, we're going to actually be going greater than, x is greater than -1, so we're going to be going towards the rightwards. So those are our two graphs right here. Just put that a little bit higher for you guys. Normally when you're graphing, you would put it right on the number line itself. But in this case, I want you guys to be able to see the graph entirely. So I'm going to try and bold it and not do that. All right, so now that we have our two graphs here, you can see this is clearly an OR inequality, compound inequality. There is a clear gap in between here that doesn't show a fluid graph, and they go in opposite directions. And just an easy way to memorize this is that x is smaller than, or just to learn this, and just to keep this in mind theoretically so that you can think about it, not actually have to memorize it. X is smaller than the lesser value, so it's going to always be going towards the left infinitely, and it's greater than the largest value, so it's always going to be going to the right infinitely, and they're never going to really converge. It's always going to be that small gap or large gap in the middle. And this also works for greater than or equal to inequalities, just like your less than inequalities. Always works. All right, everyone. So thank you guys for sticking around through this video. I hope it was informative and helpful. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below. Also turn on post notifications and utilize that comment section down below as well. Check out our website at www.eCoreAcademy.org. We have full unlocked access to everything we offer as a platform. Quizzes, note sheets, and worksheets go along with each and every single one of our video with all these separate access features. All you have to do is make an account for free. Also, utilize our email at eCoreAcademy@gmail.com if you have any questions, and check out our socials in the description box down below at Pinterest, Facebook, Twitter, Instagram, and TikTok. See what kind of interesting content we have there aside from our YouTube channel and our website, and also utilize those platforms to share all of our videos as well. So thank you guys for joining us. This has been the eCoreAcademy learning platform, and this has been AJ Raj with this Algebra 1 video. We've just finished up our second chapter, and we got many more videos to come. So once again, I had a blast making this video, and I'll see you guys in the next one. Peace.